Hi folks, today we're going to talk about the commutative property of addition. So let's go ahead and take apart this word to kind of understand what the commutative property is. So the commutative property has this clue word in here, which is the word commute. I want you to think about if you've ever heard the word commute before. Well, commuting means like going back and forth. So an example would be when I get in my car and I drive to the school and then I drive home. That's my commute. Drive to work, drive home from work. That's commuting. So the way that commuting works with addition, because this is, of course, the commutative property of addition, is that if I were to add two numbers, let's say I added A to B, I can also do it backwards. I can commute. I can change up the order and say B plus A is the same thing. Let's do an example with some actual numbers. Let's think about if I were to do the problem 6 plus 2. 6 plus 2 equals 8. Of course, our sum is 8. Now, if I were to change the order and I instead did 2 plus 6, I would still get a sum of 8. So the commutative property of addition is when you change the order of your addends and you still get the exact same sum. Now the commutative property only works with addition and then also multiplication. But for the sake of this video, we're just going to talk about addition. It does not work with subtraction. So for example, if I were to do 5 minus 3, and switch that to 3 minus 5. Well, 5 minus 3 is positive 2, and 3 minus 5 is negative 2. So you can see that it does not work with subtraction at all. It only works with addition. So why is the commutative property important? The commutative property can help us to rewrite our problems so that it's a lot easier for us to solve. And that's the reason I've been telling you to rewrite all of your subtraction as adding the opposite. So if you've been wondering, why, Miss Urban, do I have to continue to rewrite my expressions as adding the opposite? Why do I have to write it as a sum? The answer is because then we can use the commutative property of addition. And we can't use that property if we're doing subtraction. So let me give you an example here. Let's say we're doing 3 minus 8 plus 5 minus 2. Now, I already showed you an example where if I try and switch the order around here, while I have subtraction, it's not going to work. I'm going to get a different answer. But if I change it to adding the opposite, 3 plus negative 8 plus 5 plus negative 2, now I can rearrange it in whatever way I want. And this is going to help me because then I can add my same signs together. So I can rewrite this as my negatives first, negative 8 plus negative 2, and then my positives, plus 5 plus 3. This way, I can add my negatives together, and I can add my positives together. And it makes a much simpler problem for me to be able to solve. So negative 8 plus negative 2 is, of course, negative 10. And 5 plus 3 is a positive 8. Now I can do my different signs. So I'm going to subtract them and keep the sign of the bigger number, and I'll get negative 2. So you can see that using the commutative property of addition can help us to rewrite our expressions so that it's a lot faster and easier for us to simplify or solve. So let's do a couple examples of remembering how to add the opposite. How do we actually do that? So we're going to review changing subtraction to adding the opposite. We're going to start with 9 minus 5 minus 3 minus negative 8. So starting with 9 minus 5. If I think about 9 minus 5, 0, 9. Well, when I subtract 5, I go to the left on the number line. And when I add 5, I go to the right on the number line. So I know that 9 minus 5 is not the same as 9 plus 5. So what is the same as 9 minus 5? Well, subtracting is the same as adding the opposite. So instead of subtracting 5, we would add -5. The same thing goes for when we subtract 3. Subtracting is the same as adding a negative. So I would add -3. Now here's where it gets a little weird, because I'm subtracting a negative. Subtracting a negative number is the same as adding a positive, because we are adding the opposite, and the opposite of -8 is +8. So subtracting a negative is the same as adding a positive. So this would become +8. Now I can use the commutative property of addition to rewrite this to put my negatives together and my positives together. So I would rewrite this as, let's do our positives first this time. 9 plus 8 plus -5 plus -3. So when I add 8 plus 9, I'm going to get 17. And -5 plus -3 is -8. Now at the very end, I have my different signs. So I can subtract them and keep the sign of the bigger number, which will be positive in this case. So I'm going to get 9 as my answer. Let's do another example, but this time with some rational numbers, with some fractions. So this problem is 1/5 minus 3/5 minus -1/5. The first thing we're going to do is add the opposite. So I have 1/5. Since I'm subtracting a positive 3/5, I'm going to add the opposite of 3/5, which is -3/5. And here, since I'm subtracting a -1 1/5, to add the opposite, I would add a positive 1 1/5. Now I can go ahead and rewrite so that I'm adding my positives together here. I only have one negative, so I'm just going to put it at the end. So I have 1/5 plus 1 1/5 plus -3/5. When I combine 1/5 with 1 1/5, I get 1 2/5. So if I have 1 2/5 and I'm adding a -3/5, I'm going to go ahead and subtract here. So there's a couple ways that I can do this, because I can set this up like a regular subtraction problem, and I can actually borrow from my 1. And since 1 is equal to 5/5, I'm going to add 5 up here to get 7/5. And 7/5 minus 3/5 is 4/5. And the final way to do it would be, well, I can turn this into an improper fraction. So 5 times 1 is 5 plus 2 is 7. So if I have 7/5 plus -3/5, that will give me 4/5. So you can solve this however you'd like, as long as you continue to follow your adding integer rules. So that's it for today. A reminder of why we always change subtraction to adding the opposite. We do it so we can use the commutative property of addition to help us solve these types of problems.